Go ahead.
All right. Hi, everyone. My name is Eli. This is Edan. We were both interns for the Argo team these past few weeks, and we wanted to present what we've done so far.
So the first thing we started working on was contributing to Kubernetes, and more specifically, the Kubernetes dashboard. And for those of you who don't know what that is, it's a UI that can check on like the health and the logs of resources. So in order to start, we had to learn some Go and AngularJS. While we had some experience with programming, we didn't really have any experience with those two. So the first couple of weeks was sort of deploying the dashboard and also learning Go and Angular. And then we started to look for some good issues to solve on the dashboard. And while we were looking through the source code, we just started to understand more and more about Kubernetes. Keep in mind, this was we didn't know anything about containers beforehand. And
I love it already. Good start.
Kevin really loved it.
I guess one thing we really learned about this is that the dashboard team was incredibly unresponsive. Even then, though, we still managed to get 2 PRs or 4 PRs and 2 of them approved.
Nice. Very good.
All right, so the next project we worked on was an Argo workflow demo. So our goal was to use DAG steps, conditionals, and some machine learning aspects in an Argo workflow. And this way, there'd be a workflow the team could use that used a lot of the features Argo has. So to start, we followed the guide and we installed Argo on the Google Kubernetes engine. And then we had to think of an idea. So we thought a cool demo would be to take a 2D image, just like a group in image, and then convert it into several 3D face models. So to do this, we had to overcome several hurdles. The first one was we had to find a good face recognition algorithm. So we started using OpenCV, a common computer vision library, to detect faces. And we followed some guides and used some models they had already. And the facial recognition results weren't that good. So we ended up using another person's project, which used a more developed model and it had much higher accuracy. Another issue we had to overcome was preemptible GPUs, which was a feature Google Cloud has. And basically, whenever we wanted to use GPUs in our project, we'd have to wait for G-Cloud to find the GPUs and allocate them to our pods and stuff. So we still kind of have some issues with our workflow, but this could definitely be fixed just by having a dedicated GPU in Google Cloud. But for now, we can only run one workflow at a time for some reason, just because of these preemptible GPUs. We also had to integrate buckets into our workflow because we're using large files for these 3D images. We're passing them between different steps in the workflow, so we had to integrate buckets. Finally, it wasn't clear to us how to use GPUs with G-Cloud. In fact, they were recently added this year. So we started by implementing CUDA, but eventually we just decided to use Kubeflow and TensorFlow was built into Kubeflow.
Yes, so in order to get TensorFlow running, we also decided to use Kubeflow, which is essentially, it makes container-based ML a lot easier, makes it more organized with custom resources, and it makes it more efficient utilizing the Kubernetes API.
And it's also open source.
Yeah, open source. Yeah, and it does come with a couple cool features. One of them is Jupyter Hub, which uses, it uses the Kubernetes nodes, so the GPUs and the CPUs, and it's really good for testing your Python, your machine learning workflows. It comes with all the built-in dependencies you need. And also there's TF training and TF serving. TF training is for training your TensorFlow models, and TF serving is for once you have a pre-trained TensorFlow model, you can deploy it. And also, if you look at the Kubeflow logo, it's KF. Here, I guess you can see on the left, we did a quick kubectl get pods, and you can see a couple of the TensorFlow jobs that come integrated on. Yeah, right over here, there's this TF hub, and then there's these ambassador pods. So there's like also pods and there's a bunch of other resources, but it just like once you deploy it, it automatically gives you all these cool things. And also over here you can see like the Jupyter Hub login. It's like really easy to use. All you have to do is like either go through a load balancer or port forward to this URL, and then you have like a TensorFlow image you can choose from, the amount of CPUs, the memory, and most importantly, the amount of GPUs you can use to run your Jupyter Hub.
So our experience with Argo workflows, this was our first time using it, and we had to learn it all. So our impressions were is that the interface was really visually appealing. Another positive thing was that repeatedly deploying projects was a lot easier than we expected. We just would run Argo delete and Argo submit again over and over again, and that was a lot easier than some other projects we had used. Also, the live view was really helpful for debugging. We could see the workflow happen in real time, and we could see what failed, and we could see the log messages for that. Some negative things is that for our workflow, it took a lot of vertical space on the screen just because we had so many steps. And we immediately saw some UI bugs that resulted from that. Also, we noticed when you're using Argo loops, there's no straightforward way to accumulate the results from each step in the loop. So we had to use a persistent volume plan to do that. That's fixed. Oh, no. Okay. Well, now it's fixed.
And also for the custom recursive, sometimes like getting inputs in and getting the outputs out was like a little bit hard, but it was still possible. You just had to do like a couple of workarounds.
Yeah, so here's the workflow. You guys kind of saw a peek of it, but here's a workflow we ran earlier.
The screen's like
yeah. Barely read that.
It's because like the display is like very like a small amount of yellow. Right?
So we started. This is our starting image. Just a photo we took of some people on the Argo team. And so barely read these pods. We start by downloading the image over here. So it converts an image URL, like a direct link to that image, into an artifact for the workflow. Then we have a few steps here for managing a persistent volume claim, just the way we have TensorFlow set up right now. We have a step that locates the faces, and then we loop through each face. We handle each individual face. So in this case, we have 5 faces from our image. We have 5 faces. And we crop the face, turn that face into a volume, and then feed that into one TensorFlow job. And the reason we did that is that we had 1 GPU on our cluster, but if you had 5 dedicated GPUs, you could do them in parallel. And then finally, this right here, the TF job. So what it does is it uses a machine learning model and converts a 2D face image into a 3D face model. So it does that. That's like the key component of the workflow. And then we turn that result from the PVC back into an artifact in the workflow. We also have a conditional step right over here for if no faces found. And then so here's like the outputs we got. So I don't know whose face this is. Oh, it's my face. So you have a 3D image of each face. That's all from just one group image we took. It's cool. Yeah, we have that for every face in the image. So these aren't like the previews look a little worse. But yeah. So Shree's face was like cut off just because in the image he was facing the side. Like that. Yeah, it can't handle glasses.
Yeah, I guess the final project we were working on is for training our own ML model for like a log analyzer, which would take in like Intuit logs, and then through like a recurrent neural net, it would see whether like the logs match like previous logs, like based on like subsequent wording, and if they were similar, it would email, or if they were not similar, it would email the user If they were similar, it would be used to further train our model. And the orchestration we have for that is you start with an S3 bucket, which gets, once you put in like a TXT file, it'll send an Argo webhook, and then it'll automatically deploy an Argo, like the Argo ML workflow, and it'll take its output and put it into an S3 bucket or send it through an email. Yeah, so I guess the takeaways, like we learned a lot of things here, and this was our first ever time using any cloud-oriented thing, and we learned a lot of Unix and Bash because we were constantly inside of a shell, and then we learned how to use Docker. It took weeks. We used Google Cloud a lot and GKE. We learned Kubeflow as well, Kubernetes, which was really important, and also some Go and Angular.
Yeah, we also got some experience using OpenCV, which is a really versatile computer vision library that I think will be really helpful in the future. We also got to use S3 buckets. We also used NVIDIA's architecture called CUDA. We used TensorFlow, and then we of course used Argo workflow and Argo events. And then lastly, it's not up here, but this was our first time being at such a big company, I think. And that was a really great experience seeing how all these small teams contribute to one big product that a user can use. Thanks.
Yeah, thank you so much.
I feel what you did the project is normally already a master project. Especially normally we using OpenCV to do something. Like I did the CUDA, I writing the raw CUDA. It's basically for the parallel computing. Basically you touch the very single bit of it. It's very, I would say very helpful, but you will see, oh, you already know this. Then people are still dragging, so oh, what is CUDA? What is Kubeflow? What is Kubernetes? But you can already actually deliver something end to end. It's a very good school project already. I mean, yeah.
Very impressive.
Yeah.
You are coding the GitHub? Oh, where's your code?
Yeah, it's currently on GitHub, but we're gonna I guess next week we're gonna get it onto like the Internship.
Yeah, internships is there.
Do we have plans to productize this and use it going forward? We're not going to let this fall on the ground and get squashed, are we?
So they helped do a lot of research for us using Kubeflow and TensorFlow, and we want to use those for more.
I
Our
agree.
machine.
Right.
They
So
need to come back to finish now.
right. So
You don't need to go to school.
you guys are what? You're in
High
college.
school.
You're graduating college.
No, they're high
Getting your
school.
master's.
They're
degree?
high school.
All right. So Pratik, are you making them offers?
We're hoping they're going to be back here every summer.
Well, let's get them under contract. Right. So what's next for you guys? I mean, so you're going to go to school, but school's boring compared to this. So what's next?
Other things to school than projects.
Eli, why don't you tell us where you're going?
All right, sure. So I'm an incoming freshman. I'm going to Brown University, and I think I'm going to study CS. Or I know I'm studying CS, but I'm not sure what I'm going to do with that major. I kind of like robotics. I like computer vision, but I also kind of want to play around with bioinformatics. So I really don't know where I'll go yet. So I'll see.
Yeah, I'm going to University of Washington up in Seattle, and I guess I'm really interested in computer science, and like I definitely know I'm going to be doing something inside of computer science, but I'm completely unsure about what I want to do with computer science because there's so many cool like things I guess in between. So I'll just have to figure it out.
Awesome.
And does this, I mean, how are you thinking about this project? Like, is it like kind of a demonstration of Argo, or is it an open source on its own, or how do we?
I guess like the middle project is more of like a demonstration of like all the cool features of Argo, and it's also like, yeah.
So it could be used as like
Kubeflow.
evangelizing Argo to say like, here's how you could use.
Yeah, we've already used it a couple of times to demonstrate to the ML teams here.
Okay.
Yeah, it came in really.
So most of the Argo users actually use Argo for ML.
Right.
And we don't use it here.
Right,
So we
right.
were looking for some help to
Right.
start off the process
Demonstrate it.
within Intuit.
but then we can make that part. I mean, should this be part of the Argo open source
Yes,
instead
we
of
want to use
internal?
this as an example.
Okay.
firstly.
Well, I imagine we'll probably use these in demos like QCons and stuff like that.
Okay.
Yeah.
Both for Argo and Kubeflow because we work very closely with the Kubeflow.
So now you're in Seattle, and you're in Seattle in December,
Yeah, I guess.
so we can get you a ticket to
November.
KubeCon.
You can come and man our booth.
And you could co-present too.
Yeah, yeah.
Yeah, you can do that actually.
Yeah.
Yeah, the thing is, we know that our data. So they are starting. First,
Actually, they plan to use it for their next production project.
Yeah,
Awesome.
because I think they're running it on Kubernetes anyway, the inference.
Right.
So they're gonna try to figure out if they can do training on.
They really hate the workflow engineer.
Yeah.
That makes it a little easier.
great. Well, listen, thank you. It's
Thank
been
you.
a pleasure having you guys here.
Yeah. Thank you.
Fantastic.
Thank you.
And, as I said, look forward to seeing you guys back here.
Yeah.
Thank you very much.
Cool. Thanks.